Okay, so we're looking at the side that says apothegm, and then it gives you the definition of it because apothegm is a new word that you probably haven't heard before. And so what I want you guys to do is to draw 3 apothegms on this, and it tells you what it is. Okay, so this is what mine looks like. You can actually draw an apothegm like on all the sides. So there's 5 apothegms for a pentagon. There's 3 apothegms for a triangle, 4 apothegms for a square. Okay, I mean, it just goes from the center of the shape to the midpoint. A radius would actually go from the center to a vertex, and we will talk about a radius, just not right this second. I'm also going to add this in there because these are all always going to intersect the side at a right angle. An apothegm will for a regular polygon. All right. We are talking about area of regular polygons today. All right. What is a regular polygon? We're doing area of regular polygons today. It's a polygon is, a shape that has straight edges. Regular polygons is a shape that all the sides are the same. So like a pentagon, all 5 sides are the same. A hexagon, all 6 sides are the same. An octagon, it looks like a stop sign. They're all the same. All the angles are the same. That's what a regular polygon is. In order to solve for the area of regular polygons, we're going to use this formula. Area equals apothegm. Okay, think of our geometry vocabulary and think of a word that starts with a P. What do we think it is? Perimeter is correct. If you thought something else, you're wrong, but that's okay. So the apothegm, which we just drew, times the perimeter divided by 2 will find the area. And ultimately what it is it's the length of all these. It's just like it breaks this up into different triangles. So apothegm is like the height of the triangle, and then the perimeter is the base of all the triangles, then divided by 2 because that's the area of triangles. So what we need to do first is draw in our apothegm, and then we're actually going to draw the radius in as well and create a right triangle. So this is the radius that connects the center to the edge. And then things that you can notice is we're going to find the central angle, which this technically is only half of the central angle because the central angle is technically the entire triangle, but we're just going to call it the central angle because it's the angle of this triangle that we've drawn. So 360 divided by 2 times in it changes based on the shape because it's not always a 5-sided shape, but in is just like the number of sides. So yes, 360 divided by 10, or 2 times 5. Please don't write 25 there. 360 divided by 10 is, 36. So that is this angle right there. That is in the center of our shape. And then we have to determine, okay, what are we given and what do we need? Well, we need the apothegm and we need the perimeter. We already know what the perimeter is because we know all the sides are the same. So if each side is 10, there's 5 of them. Our perimeter is 50. That's pretty easy. But our apothegm we don't know. So I'm going to put an X there because we are going to solve for it using trig. If you don't remember how to do trig, we're going to have, we're going to remember. But for the most part, you guys did well on the trig test, so not too worried about it. This is half of the side length, so you have to remember to cut that in half to figure that out what the side length is. So that's where the 5 comes from. It's just 10 divided by 2. And then we need to use trig to solve for the apothegm. So we are going to use tangent because we have the opposite and the adjacent. We don't have the radius and we also don't want the radius, so which is the hypotenuse. So we're going to use tangent of our angle equals 5 over x. So write that down real quick and then I'll talk about it a little bit. All right, and then x is on bottom. Who remembers if we multiply or divide? Oh, good. Y'all remember, good. So we're going to do 5 divided by tangent of 36. So type that into your calculator real quick and make sure your calculator's on degree and you're getting that answer. We're going to talk about rounding.
5 divided by 10.
This is my apothem. That's my perimeter. I'm not going to round early. So my apothem is this like 6.8819 dot dot dot. And then 50 divided by 2. So how do I type that in my calculator? I have to have this in there, and then I use my arrows and I go highlight that number. And then I click enter, and then it appears below there, and it has not been rounded. And then I click times 50. And then I can go ahead and do divided by 2 now, or I could wait and just divide by 2 here. So the capital A is area, and then the lowercase a is apothem. But the apothem is, this is the formula. Apothem times perimeter divided by 2. So now you can round, which this one ends up rounding to 172, and then just nothing. Because if we round to the nearest tenth, it's 172.0. You're welcome to write 0.0 if you'd like. But yeah, all right, turn to the back page. All right, this is a little different because there's 6 sides. So it's 360 divided by 12, which is 30 degrees. I'm going to also draw in my triangle. We are given the apothem. This is the apothem, yes. Well, we have to use trig to solve for the perimeter now. Yes, so you've got a couple options here. You can do 30, 60, 90 triangles, or you can use trig if you'd like. It's up to you. If whatever you know how to do, you will end up getting the same thing. I think I actually rounded this one because this is the square root of 3. So it will kind of actually mess up on this one. But yeah, for hexagons you can use 30, 60, 90 if you'd like. Alright, we are going, I'm just going to use tangent though. So tangent of our angle equals, we have the adjacent side, we do not have the opposite. We are looking for the side. And then runs tangent of 30. Since x is on top, we're going to multiply. But I'm not going to take this number out of the calculator before I solve for the perimeter. What is your question? Solve for the little box. There will not be one. You can, but we don't have to. So we're going to take this number and we're going to use it to solve for the perimeters. Because the x is like 0.9814, da 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 da. It just goes on. But let's turn this into the perimeter. Alright, how do we do that? Well, it's half of a side. So you need to multiply it by 2 and then multiply it by the number of sides. Which is the same as just multiplying it by 12. But if it makes you less confused to just multiply it by 2 to figure out this side, and then multiply it by the number of sides, you can do that. But you are ultimately taking the length of this and figuring out the entire perimeter. Since this is half a side, we need to multiply it by 2, and then also multiply it by 6. We've already talked about that. And then we're going to multiply these numbers now. So the apothem is 1.7 times the perimeter, which is this number that's in my calculator. And then I'm going to divide it by 2. And this one is actually just going to be 10 as well. So this is an octagon. 360 divided by 2 times 8, or 360 divided by 16 this time, which ends up being 22.5. And I'll write it really small right there, 22.5. That's this number right there. We don't have the apothem or one of the sides to figure out the perimeter, unfortunately. So we're going to have to do trig twice on this one. So I'm going to call this x, I'm going to call this one y. Because we've got to figure out this in order to figure out the perimeter. We've got to figure out the apothem in order to figure out So we are not going to use tangent because 6 is the hypotenuse. We're going to use both sine and cosine. So let's do sine first. Why not? The sine of my angle, which we figured out in this first step, equals y over 6. The nice thing about all these is you're multiplying both times. So that's good, I guess. Let's think of the positives here. Make sure your calculator, oh, it didn't sine of. All right, make sure your calculator is still in degree. 6 times sine of 22.5 is going to give you this number. What is this? This piece. This is going to help us solve for the perimeter. So we've typed it into the calculator, we have this, and then we need to figure out what is the perimeter based on what y is. It's like, and then just all these. So use this to figure out the perimeter. So I'm going to go up here and I'm going to grab this, and I'm going to multiply it by 2, and then that gives me the length of one side, and then I need to figure out how many sides there are. There's 8. You could also just multiply it by 16, and that would be fine. And then you're going to get 36.737, because we're not going to round it in advance. Then you need to solve for the apothem, so I'm going to use cosine to solve for the apothem. Basically, anytime you're given the radius, you're going to end up using sine and cosine both. Okay. The other ones, you're always going to use tangent. So 6 times cosine, this gives me my apothem, 5.543, all those. All right, so this one's kind of annoying because there's two like unsimplified, or not unsimplified, unrounded numbers that you have to go grab up in your calculator. But if you do it like this, they're just these two numbers right here. So you can find the apothem, which is this, and you can multiply it by the perimeter. But the way you do that is you have to highlight these, go back up and highlight them, click enter, and then divide them by 2, and you're going to get 101.8. So your apothem times your perimeter divided by 2 is going to give you your area.